Okay, now we're going to try this with the lights on, because I apparently wasn't very visible in the last video. So, hopefully you've tried the second problem. Maybe you got stuck, so that's why you're viewing this. We've got a car that passes along a certain point at 1 p.m. and keeps going. An hour later at 2 p.m., the second car passes that point at a faster speed. Now, since the second car is going faster, it should approach the first car. The question is, when? So we're going to start this by defining a variable. Let's say x equals, I know this might happen, where the variable is not exactly what answers the question. We probably wouldn't deal well with the 1 p.m. part of this question. So instead of the chronological time, so like 4 or 5 o'clock p.m., I'm going to use hours the first car has been on the road. You could also do hours that the second car has been on the road, but it's neither here nor there. So hours first car is on road. So let's get our chart ready. So we've got first car, we've got second car. Okay, so we've got rate, time, and distance. So the rates come right from the problem. So we've got a rate of 64 kilometers per hour, so that's the first car, 64. The second car is going at 88. Now, here's where my choice of variables seems a little bit more intuitive. So I chose x for the time that the first car was on the road. So that makes a very obvious choice for x. Now, a lot of students make a mistake here. They think that because it left an hour later, x plus 1 would be a good choice. That's not entirely true. Let's do a little bit of prototyping to kind of feel this out. If the first car that's been on the road longer is traveling for 4 hours, that's just an arbitrary number I pulled out of the air, 4 hours. If the other car leaves an hour after the first car, then it's been only traveling for 3 hours. So that would be x minus 1. And that's the real sticky part of this problem. Now again, there's no mention of distance in the problem, and we don't really need one. We have 64x, and we have 88 x minus 1. Both of these together are the same distance. They both start at the same point and they end at the same point. So the two distances are equal. We have 64x equals 88 x minus 1. Distribute. 64x equals 88 x minus 88. Now subtract 88x. And we should get negative, let's see, negative 24x equals negative 88. We divide by negative 24 and get x equals 3 2/3, or 3.6 repeating. Now remember how we defined the variable. That's how long the first car has been on the road. If the first car left at 1 p.m., then this corresponds to 4:40, because 2/3 of an hour is 40 minutes. So 4:40 p.m. And there's the problem.